also one of our ambassadors for Vids Kerala.
Okay.
Yeah, this is my first year in with. Julian has been here for like 3-4 years, right?
Glad to meet you.
Julian, we can get started. It's what time is it? It's already 6:06. You want to get started?
Yeah, sure. So, hello everybody. Welcome to our second talk of 2021. I'll just begin with a brief introduction on why and what we're doing. So, Vids Kerala is one of the regional chapters of a global initiative. This entire initiative started in 2015 at Stanford by Margaret, and on that year, in that year, it was just held at Stanford, but they've broadcasted it live to other cities. And what happened was the next year, it kind of happened in multiple cities. And every year since then, we have had simultaneous chapters, simultaneous annual data science conferences taking place in almost 175 different places. So in India, there's one in almost every other city, but Kerala didn't have one of their own. And last year, there was a comment on LinkedIn, as in where can I join one in Kerala. So we started it this year for Kerala. Why? Because I think there are a lot of data scientists already in Kerala. I know a lot of people who are into a lot of technologies there. There's no dearth of technologists in Kerala, and there are a lot of students who are studying there as well. I myself have studied in Kerala, and engineering colleges in Kerala have electives like neural networks, information retrieval, and stuff like that. So Vids is basically trying to make sure that we provide a platform where you can reach out to industry experts like the one that we have for you today, and get to know what data science is being used for, how is it actually looking like once you get inside a company, become a data scientist, the entire process of becoming one, what all you have to learn for it. And it is also to inspire more young girls to join this field, to take this up as a career. So that is basically the motivation behind starting this. And our plan has looks like this. We had a 5-day datathon workshop that just got over on Feb 6th. It's available on YouTube. We'll share the links. And currently, we're planning 2 tech talks every month, which will happen in closed sessions like this on Zoom. It'll also be available on YouTube once it's over. So you can see our first talk, Deblina's talk, on YouTube. We'll be having all throughout the year, after June, we'll be having podcast interviews with folks from working in the field of AI. And we're also planning to reach high school students via the outreach program of WITS. This is also officially started from Stanford. We're hoping to reach schools in Kochi and Mumbai and other places. Currently, folks like me, Binita and Prashansa are ambassadors for WIDS Kerala. We are collaborating with WIDS Mumbai, the chapter that I had started in 2018. I was running it for the past 3 years, but now that I've come to Kerala, we have now a new chapter in Kerala. So we're always doing these things in collaboration with WIDS Mumbai. Those are our 2 chapters. So you will have students from Lokmanya Tilak College from Mumbai today, and from CET Trivandrum Engineering College. So these are the 2 colleges we have in collaboration for today. That's just a brief about about us. I hope you guys enjoy the session for today. I'll let Vinita take over the session.
All right. Thank you, Julian, for that introduction. And thank you, everyone, for joining. And good evening to all of you. So today I would like to introduce Mathangi Shri, who is our speaker. She's also a top 10 data scientist in India and a top 100 women in India recognized by INBA. So Mathangi has been in the data science landscape for the last 15 years and has worked in some of the uh, top companies like 24/7 AI, Citibank, HSBC, PhonePay. She was the head of data science at PhonePay, and then currently she is with Gojek. Well, she heads the data science division over there. Um, Matangi has also been in an advisory role with Nano Local Technologies, where she primarily helped set up the data science division. Mathangi is a top influencer in the data science community, and over the years, she has contributed to the community with more than 20 patents across ML, NLP, and more. Mathangi also actively attends many conferences and summits where she presents about the latest developments in the data science space. She has 6 publications to her credit, and she's an author of the book Practical Natural Language Processing with Python. As mentioned before, currently she is the head of data science at Gojek. She is also a visiting faculty at Praxis Business School and a guest faculty at NIT Trichy. I know, Matangi, I'm doing injustice by kind of cutting down on your introduction. So I would pass it over to you to complete the gaps. And yes, you can take over and get started with the session. Thank you so much for being the speaker, agreeing to be a speaker today. It's an honor to have you in the session. Thank you. And over
Thanks,
to you.
Vinita. Thank you, Benita, and thanks for the kind words. Yeah, I'm just passionate with data, and fortunate to be part of few of the institutes in the country to either take a course in their data science program or kind of be thought partner for designing the curriculum as well. Yeah, so very happy to see Vids kind of encouraging, especially women in data science. It's a pleasure to be always part of Vids event. Uh, with that, I want to today thought of there's been a general common question about what is data science. How does a career in data science look like? If we have to, if women have to join the workforce of data science, what does it take, right? So that's kind of the topic today. And what I will do, I'll go through the presentation. Maybe I'm thinking, Benita, if this is okay, I'll kind of pause after a few slides and then ask for questions. Is that fine?
Yeah, yeah, absolutely.
Okay, cool. So we'll get started on the content today. I need to do screen share. I don't have access to do screen share.
Julian, you will have to make Matangi a co-host
I
so
have,
that.
I have. Could you please try now?
Yeah, I can do it. I think everyone is able to see my screen.
Yes, we can.
Yeah.
Yes.
So, like I saw when I was preparing for the talk, there's a bunch of titles I was looking at online portals, and these were some of the titles in the world of data science and analytics. There is too many of them, right? And everybody calls different roles differently, right? uh, Especially like you take risk analyst, and what is a disk, for example, a difference between a risk analyst and a research analyst and a quantitative research scientist, to a data scientist, to a business intelligence scientist, to a solution engineer in the space. There's plenty, right? There's a finance analyst, financial analyst, policy analyst, etc. So of course these are fancy, but um, and there is some element of truth in some of these titles. Maybe it is very specific to the domain at hand, etc. But fundamentally, and there is, as we know, this tons of hype, and a lot of people wonder what this field is today and how should they recruit, what kind of talent they should attract. So there is almost a version that everybody has on their own, and combine it with their domain, so you get a bunch of titles. So and from here, we'll see. We'll only distill out the prominent ones. These are kind of, we can say, mother of all the titles that we saw. And these are, we'll see why these titles are there and why each job is different from the other. Though when I started out in this field, all of us were part of the whole wide world of analytics. But from there, it kind of became, a lot more granular, a lot more specified, etc., which kind of indicates the growth of the industry, right? And as well as growth of the data. So to step back and talk, so there was at a point where there was data pipelines and things like that, but then a lot of work was happening through statistics, a lot of work was happening through analytics, etc. But this field actually grew out into data science. A part of the field stayed into analytics, and part of the field grew into data science. And with that came a lot of challenges that had to be addressed. One is the massive growth of data. So the data pipelining, serving the data real time, etc., became more critical than what was in the past. That kind of led to different roles, and also people's interest, the kind of skills you need for these jobs started getting evolved. A lot of algorithms got dusted out from the archives, right? So, and kind of there was titles very specific to core algorithm, and there were people who were completely into research, trying to apply some of these algorithms into real world problems, right? So this led to this particular phase of this explosion of data, followed by enhancement in infrastructure of being able to process the data, plus the need to serve consumer at real time, make decisions for consumers at real time. Also kind of trying to personalize services or products that a user consumes. The use cases for it also helped this field, and also created a bunch of different verticals for this field to happen, right? So this is, I had put out the classification of different roles based on, based on the life cycle of how a project gets deployed, right? Like how a data science project gets rolled out. So everything starts with data. So that's where your data instrumentation systems are there, which is your, fundamentally these are your client systems. These are the ones that is kind of generating the data, right? So this could be, for example, if you're buying in one of the e-commerce portals, this set of layer is recording your click event, it's recording your browsing history, your login events, etc., right? So there is somewhere the data is getting sourced from, and possibly this system is also connecting to your merchant systems, and then there's tons of information that is being fed about the merchandise that you're buying, which is which could be let us say a shirt that you're buying, and then the properties of the shirt, etc., gets instrumented from that system, right? So data instrumentation is about collecting and sourcing the data right from the source. Now these are like large volume data at scale, very high velocity data, and hence they need to be properly saved so that later it can be mined, right? So there are real-time systems which is kind of getting data at scale and then processing them or taking decisions at scale. So those kind of becomes a data engineer kind of role. And from there, these systems, this data gets piped into a stagnant system, so to say, which does not have a lot of requests per second as your real-time systems have. And this is your data lakes and data storage. Fundamentally, your data storage where your data lakes or BigQuery tables or any other data warehouse tools get created. So fundamentally, this is your static pool from which you are going to static well of data from where you are going to process the data, right? After this, comes the data processing stage, where somebody is quickly processing data, possibly generating some reports, then some analysis, and then there are algorithms that is going to sit on top of either the data processing output or directly from the data storage. And then you want these algorithms again to get back into your data instrumentation layers that we started with, which is fundamentally your deployment system, right? And yeah, so let's talk one by one of these roles in depth. So data engineer is where the the high velocity data pipelines are sitting. So basically these are your Kafka pipelines or a bunch of these pipelines here, and from there there has to be some storage that kind of gets into BigQuery, etc., and then some quick processing that can happen on these large storage with your Spark, etc. A lot of data engineering will have to do with all of the three or one of the three, and they use some of the tools that is listed here, right? And data engineering again is a stream. A lot of colleges kind of, or institutions, right, offer data engineering as a course where they teach you all these tools, where they help you to figure out how to build data pipelines so that a AI solution can kind of go live and provide that business impact. Data analyst is somebody who is kind of able to crunch data at scale and provide these reports and dashboards for others to kind of take a decision, right? So you are good at SQL, you are able to connect to some of the big data tables that we saw, or you are able to write your BigQuery, and then you are good at also some level of visualizations. But the idea is you are consuming data at scale, and then you're making these reports so that there are business users or product users who are able to consume these dashboards and reports, and possibly more than decisions, what happens at this stage is possibly people are able to monitor some of these things that happen, right? So this is less about decisioning, but also about monitoring, alerting mechanisms that comes out of this step. Business analyst is a little more involved than data analyst from that perspective. So we saw in data analyst thing, the data is getting analyzed for somebody else's decision making, whereas a business analyst, product analyst also applies their hypothesis, their thought process, their involvement in the business, their understanding of the product, etc., to provide some actionable recommendations, to the right stakeholders, right? So this will be a role that is very facing business or product, understands their domain very well. So for example, some of the titles we saw in the initial slide about financial analyst, or risk analyst, marketing analyst kind of things would fit here, because they are very attached to a domain and they understand the domain very well. They are also able to think, for example, proactively before somebody asks a question to them. For example, typical questions that they would answer is, why is the sales going down? Why is the profitability not going up? What are some of the things that we should look at if we have to run a marketing campaign? Or things like, hey, if you want to run a campaign, what should be the right time period for the campaign? Or we normally see the churn rate to be X%, but now suddenly for the last 2 months, the churn rate has been going higher, and what should be the reasons? What do you think are the drivers of churn? Things like that, right? Which also involves a why question, and it involves looking at different data sources, also understanding what the business or product has in mind, or any other stakeholder for that matter, and being thoughtful and being able to give them the right solution would be the role of this. So typically I would recommend for a startup, for example, if they're setting up a team, and if data science is not their core, if that is not their core core platform on which their product is selling, maybe this is one of the team that they should start with in the data science area, right? So you do need product and business analysts to understand what is your typical customer journey look like, where do they drop off, where should it get intervened, etc. So this could be an initial team that kind of starts consuming data for the organization and giving them recommendations from where things can take a shape. Because for a company that is just starting up and want to know a little bit pulse of the market, etc., data science at the beginning might be an overkill, but it is also good to have a team like this to keep eye on the reports and to keep an eye on the data and to see what should be next done. So this is the possibly the most talked about title in this entire set of titles that we talked about. It's interesting, certainly data science is an automation of thinking, how computers automated the ticketing process and any manual process. Data science kind of automated how people think, right? And hence it's a lot of meteor thing, so to say, happens in this space. But it is not only like possibilities, some crunching of numbers or looking at and sifting through tons of research papers. There's also a lot of practical applications that happens here. In fact, generally it is perceived that some of the data science that happens at scale in the industry is about applied research, right? So it's not like how it is visualized, where people are writing equations on a glass panel, right? So it is about also being very practical, being well connected to the problem at hand, and then also having algorithmic knowledge, also having your fundamentals in mathematics, having a good amount of programming skills, understanding the underlying data systems play an important role for data science. So I saw a hand rising. Maybe this, I think, is a good time to break for questions.
Okay, so if anyone has any questions, you could either post it on chat or you can take it up with Mathangi on the spot for a question.
Okay, they saying voice wasn't clear.
Okay, is
I don't
anyone
know.
else facing the same problem?
Actually, Vinita, when you speak, it's breaking a little. Mathangi's was clear for me.
Yeah, so I am having some internet issues because I can see my internet connection is unstable. Uh, but I guess I could hear Mathangi well.
Okay, okay.
So we move on. Any other questions from
Purvika,
anyone?
any part of, yeah, I mean, if there is anything that Purvika you have missed, you may want to call it out in the chat. Mathangi can take that up.
Okay. So again, this field itself is kind of getting into a lot of finer areas. So there is a field called decision science, which is branching out from kind of data science. There is computer scientists are kind of computer vision scientists are kind of treated separately. Then you have specialists into the area of NLP. There are specialists into audio mining and voice mining, etc. But broader, all of this comes under data science. So ML engineers are people who can take these large scale, who take actually these algorithmic model and apply it to large scale consumer data, right? So for example, let's take a recommendation system that happens on e-commerce site. Now, these recommendations have to happen possibly in milliseconds for millions of users who are logging onto the website, right? And hence these algorithms that running has to have scale, and hence their latencies and things like that have to be kept. Sometimes or take what is called as edge computing, where you will have to run models or predictive algorithms at the devices, right, on your phones, right? So they are not large scale data, but then they have very little memory to run this at scale, so to run this at speed, right? And hence there are people who are specialized in this, who kind of consume these algorithmic output from the data scientist, and they are able to optimize the solution and yeah, and kind of optimize the solution and bring it to life, right, and bring it to production. So and things that is needed is, to some level of algorithm you need to understand as an ML engineer. You should also have some bit of fundamentals in math, some certainly good level of programming. You should understand this, deployment systems. You should be able to execute algorithms at scale. You can rewrite algorithms where it needs to be, right? Because a lot of things is like when you want to like run a Python model, for example, on the phone device or etc., you will have to convert it into some language that is compatible. Yeah, in order to run the system. Sorry, I heard something. Is there a question or something? Could we get that link that was mentioned about list of things we need to learn? Yeah, yeah. So, Purvita, I'll certainly send the slide over to you. So I've kind of created a skill map, right, in which you have a bunch of titles and what you need to learn, right? For example, if you're a data engineer, so you need to have a lot of, a lot of update on engineering stack like Kafka, MongoDB, etc. Should also understand SQL and BigQuery, etc. Plus, you should know a good amount of Python. But if you are, for example, a data analyst, then you could live with your BigQuery and data visualization techniques like Tableau, Metabase, and the likes. Then if you're a product analyst, similar things could apply between data analyst and product analyst. The depth of it and business intuition is the difference, right? So product analyst could have more of business analyst, but would have more of business intuition as compared to a data analyst. Again, these titles are not very watertight, right? And um, uh, and so there may be companies and organizations in which one title is being called another one, right? So it is not uncommon to call data analyst to a product analyst, etc. But these are overall, if at all you were to build walls, this is what it could be. Similarly, business analyst is somebody who has a good understanding of data visualization, business intuition, some level of SQL and BQ, analysis capability. If you see analysis, I did not take till now. You require, and you also require some amount of Python, right? Because to analyze something, you do need to know up some level of business. You need to have that ability to analyze, which is very different from the ability to purely write codes or understand infrastructure systems. So data scientist, if you see, there's a lot of tick mark, which fundamentally means it needs a lot of these things. Key areas would be Python, fairly good at Python, fairly good at SQL and BQ, fairly good at analysis, very good in algorithm, good in business intuition. Data visualization is also required, but yeah, so that is let's say average to medium data visualization as well. Right, you see all these are tick mark, but you should be very good in algorithms, good in analysis, good in programming of the algorithm, which is Python in this case. So ML engineer, again, these are people who consume, remember, they're going to consume data, the algorithms from a data scientist, and then put them into large scale deployment systems. So you have they should be good at Python, they should be good in the engineering stack, they should be good in the algorithms, etc. Right? So that's how things differ. Yeah, you can see ML engineers need not be good in business intuition, need not know data visualization. Some level of SQL BQ, but need not be good in analysis, because these are not the users who are going to, these are not the set of people who are going to interact with business or product day in and day out. So, and hence that's where this difference would stand. The algorithmic knowledge again may be little lower than what a data scientist has, but for data scientists that becomes a key skill. So what does a data scientist do? This is a funny way of saying what we do. Like moment there is a data, we kind of jump in and then say we can use nonlinear or data mining technology to optimize retail channels, and finally it ends up being spam. Yeah, so, but this is, maybe this happens, but I hope this does not happen always and everywhere, right? So what actually happens? There is a lot of meetings, a lot of codes to be written, a lot of arguments to be contested with. This is how certainly a data scientist world is, especially as you become a little more experienced in the field. I'm sure it's a combination of more meetings and it's a balance between meeting quotes and arguments. But in reality, there are different phases of data science project. One is you are spending quite a bit of time, maybe 30 to 40% of the time, in understanding what the business wants, what the product needs want. Maybe roughly another 20 to 30% of the time you are figuring out how the solution that you built, how do you say that the solution will finally make a business impact, right? How do you measure business impact? So for example, if it's a recommendation system, how do you measure the efficacy of recommendation system? What's going to happen if the recommendation is not, system is not there, right? Will the entire website shut down? It may not be, right? So hence, to understand business impact, to identify success criteria, to establish benchmarks, certainly 20 to 30% of the time gets spent. And then maybe of course, depending on projects, all these I'm saying, like for a fresh for the first time around project, maybe another 20 to 30% of the time does get spent on algorithms, data, a good part of it being data processing, and then algorithm fine tuning, reading research papers, implementing those research papers, etc. So far, and then I did not, of course, include a deployment in this. There are cases, it depends on the deployment maturity and the ML engineers in the company. So if it's a with the first time around deployment, maybe it will take 50% of the project itself, right? So, and hence is where, though we may think data scientists is crunching a lot of research papers, writing those equations, etc. There are a good chunk of the time that gets spent on talking to people, aligning with stakeholders, understanding and calling out the requirement that is required for the algorithm to go live, explaining what metric we can move, justifying what metric we have moved, etc. Right? We'll see some. Just want to do a small time check. Okay, so I'll go back to presentation. So what are some of the common myths, right? One is there is a like everything can be replaced by a machine. That has been all the work of science fiction and and the likes of it. Especially there was a video that I got. I appreciate the video. It's called "Humans Need Not Apply." If all of you there can go check. So from that perspective, can data science be also run by machines? Do we need people? So one such things came as auto ML. This is, I don't know how much of it is a fad even now, but can it be replaced by machine running, like a fine-tuned machine learning? It is not, because we saw there are quite a number of steps that happens in a data science project, from talking to stakeholders, understanding business metric, coming up with business metric, figuring out a very practical solution to the problem, etc. And none of that is just machine learning, right? So a tool like AutoML can only do so much. Second is ML engineer does not play a role in algorithms. May not be, because even if you're an ML engineer, you need to know some amount of algorithm, because let's say somebody built a linear regression model, and if you have to convert that into, let's say, JavaScript, you need to know some amount of how linear regression works to start coding the model for production systems. Data science need not deploy their own models. In some organizations, the deployment is kept separately from the algorithm team. But in a lot of cases, it's kind of the lines are fusing. So if you are a data scientist, you're also expected to know how to get your models to production, at least working with some of the deployment tools available. So that would be some level of DevOps work, some amount of what is popularly called as MLOps. Analyst does not need to code. This is some question that I generally get asked during my talks in B schools. So people want to get into data science, and if they want to stay away from coding, can analyst be a thing for it? No, it is not. If you have to be anywhere in this field, you will have to write your own codes, which means you will have to crunch data. If you have to crunch data, you'll have to write your own code. And if logic is there, I think code is writing a code is just an extension of it. So this is also not true. DS is a field of research. No, it's a field. It possibly could be classified as a field of applied research. In some organizations where it is, yeah, where the timelines are very stringent, especially startups which are experiencing hockey stick growth, etc. It is not. It is not. It cannot be a field of research that you not three. Few people are not getting into a room and discussing all day and coming up with some research papers. Unfortunately, it is not in the corporate world. I mean, right, in the startup world or in the corporate world, etc. It is a meaning in academic field. In academia, anything is like a field of research, but the data science that gets practiced in technology companies are, or in any organization for that matter, are applied, right? Like applied to a problem. DS is a field of math geeks. You need fundamentally a lot of math knowledge. It does quite a bit of help in solving problems that you have not otherwise come across. But it is also not a field of only math geeks. Without a practicality, the math will be lost. Another thing is, if you crack competitive challenges, you can become a data scientist. Yeah, you can become, but that's not the only thing, right? It is not about, because in any hackathon platform, they really give you the data set with all the nuances in it. Like, it's finally a table that comes to you with a very defined problem, defined business metric. Now, that part actually takes like 40 to 50% of the real world problems, right? So, and hence only cracking competitive challenges is not enough to have good experience in data science. Business analysts don't build predictive models. There are cases where business analysts also step into the shoes of data scientists and they do build predictive models. So if you're a business analyst working as a business analyst, then you may want to try your hand at building predictive models. Data scientists need to only know algorithms and nothing else. That's wrong, because there's a lot of practicality that is involved in the field. There is a lot of data that goes into this, and hence applying the data, understanding it to the business case is very important. Apply ML models at the first instance is, as soon as you get something, trying to apply randomly some ML model is not going to help. It also depends on the use case of the problem. And the reverse is also is the true. If a data set is given, can somebody say which ML algorithm will solve it? That also is not known. That is why there is a lot of mind that gets applied. It's not like it's not a mindless automation that can be done. With this, I come to the end of the presentation. We want to take questions. Any questions on this?
Thank you, Mathangi. That was very informative. To the audience, if you have any questions, this is your chance. You can ask any questions. If you have not understood any part of this presentation too, we can take that up. Or you can post your questions on chat. Mathangi, there is a question from Pranav. How do freshers apply? Like, from which post should we start?
Like, from which post should we start? Oh, okay. It depends on your like post, as in I think you meant a career or a title, right? So it depends on what your core skills are. Career should be certainly made of core skills, right? It's not about what is fancy and what is not. If you are really interested in math, if you're really interested in kind of very passionate about solving business problems through data, then data science could be a good field. But if you are kind of more interested, for example, in the business side of things, and more inclined to solve quicker problems possibly, then you could start as a business analyst, etc. You could also, if you're a person who are interested in very engineering systems, then you could think of data engineering or an ML engineering as a career.
As an ML engineer, I have a question. Do you think it is important to start getting like I have like 3 4 years of experience as an ML engineer, like I've Python and deployments, all of that is good, but do you think it is important that I also start getting analysis experience, like business analysis, as you mentioned, is wasn't ticked in ML
Yeah,
engineer,
yeah.
as I noticed that. So but I'm fascinated with the things that a data scientist can achieve in his time period. So, how much would you suggest that I should spend time on understanding how to analyze?
If you want to grow into the ML engineer career path, analysis is not a must, right? Or deeper understanding of algorithms is also not a must. But if you want, but you are in the right place if you think so to shift into a data science role, right? The lines between ML engineering and data science are very blurred today. So if you are thinking of, and if really data science kind of a role excites you, then you should try few projects, a full-fledged algorithm kind of projects, which also has a phase of analysis, computing business metrics, etc. And then that could be one way for you to start practicing, because analysis is unlike a hackathon, right? Nobody says analyze this data. It's very difficult to judge. So analysis can come only through a job, and when you get the opportunity to do it, I think if you are interested, you should start doing it. You just pick up a project and go for it.
Sure, thanks.
As
Matangi, there
freshers,
is another question.
as freshers, can we directly apply as a data scientist? Yeah, so this is a very commonly asked question. I think at least post COVID, I do hear some openings that is happening in organizations for freshers. Even if you don't get a full time opening, I would say suggest if people are ready to take you as an intern, please do apply for that. So internship is one way for you to settle in an organization. An organization should also know. I think the that's something that I keep hearing, that a lot of openings have come after COVID for fresh talent in the industry.
Another question from my side, if it's
Matangi, one thing that I want to, sorry,
continue, continue. Yeah, Vinita, go
yeah,
ahead.
Matangi, one thing that I wanted. All right. One thing I wanted to ask and also convey to the audience here was, say, for example, when you're getting hired as a data scientist, you are not doing everything, right? You mentioned about many skills. You spoke about Python, you spoke about SQL, you spoke about analysis, and there was ML algorithms, but you don't end up doing everything, right? That one person don't doesn't end up doing everything. There is a specific set of activity that is assigned. How do you see it in your organization? How is a work split for a data
Especially
scientist?
no, especially in startups, right? There is a constraint on headcount and things like that. It is a full stack field, right? You have to be a full stack person. You may not have depth in all of this. See, you are not ML engineer deploying models, right? You're not building a platform for deploying models. But then you need to know how to use the platform, right? But you so similarly with data engineering, right? So you are not doing the Kafka pipelines, but you need to know how to use the Kafka pipelines to log your outputs or get incoming information from those systems. You should understand a little bit of how in-memory compute works, how parallel processing works, why is multi-threading important, where does Python fail, and things like that, for you to work with some level of deployment systems. If I were to, say this a little boldly, what happens is there is a lot of focus on product engineering in a lot of organization. There is a lot of focus on to get a data science algorithm output, right? But where the gap is how to take this data science algorithm to a full production, right? And hence a lot of systems are broken in that. There are mature organizations where you can deploy at scale, like deploy at the click of a button, but that's dream, right? Not everywhere it happens. So you will have to know some of these. And you would know this very well, Benita, that data is always not, in the perfect shape or form. So you have to know your SQL and processing the data, cleaning the data, etc. So that skill is also important. Data visualization is where I did not tick it, but I know in a lot of cases that is also required. But other than that, I do see a dip in every aspect and a depth in algorithm and Python.
Okay, all right. Thank you, Matangi. There is another question in the chat window. Are engineers preferred, or even management students qualify for a data scientist?
So I am also a management student. It's a practitioner's field at the end of it. As long as you can, sorry to be harsh, but as long as you can leave the degree outside and do what is required for the job, anybody can be here with the right set of passion and the inclination and alignment to solve a problem. Right skill sets. Skill sets matter. Attitude matters. Your behavior, your thinking, that matters. Not so much of your degree. You could become a data scientist or grow in that field even if you start out from a management student.
How do
Mathangi,
you
one quick thing. Julie, you go ahead. I think I already asked one question. I'll take it later.
just one question? Like I'm just curious. How do you stay abreast with everything that's coming out? There's Scala, there's Kafka, there's Tensor 2.0. Like, how do you keep yourself up to date with learning all of this, knowing how to deploy all of that?
Yeah, so you would know this better, right? There is a every second tool that is coming in the market. It is tough. I remember some time back somebody wrote a blog on how difficult it is to just stay in this field. It is very difficult, especially to have team and nurture the team, etc., and also be connected well with the team to keep updating yourself. Yeah, it's that part is brutal, right? It's not like you can learn once in a while. You're learning is happening every day. So it so happens, on a Sunday morning, if I'm just having coffee, browsing an article, and I find that, okay, I didn't know this, I immediately go freak out and start learning it. But that's what it is. It's called. A lot of people have imposter syndrome. That's what I've heard, and I certainly have. And hence it's important that somebody speaks of some technique in a meeting, and then you run up to it and then read about the algorithm, or you feel bad about the fact that you have missed a research paper. It happens all the time. I think, yeah, that's it. Meaning, it's some level is the joy of learning, as well as the there is also the pressure of learning. It's both. It's bittersweet.
Mathangi, there is another question from Nikita.
Oh, okay. I didn't see this question here. Please go.
Um, I'm sorry, I think I just typed it personally. So this is Nikita here. I'll just speak out my question.
Sure.
I joined the session midway. I wasn't really following the group chat, so I wasn't aware. I'm sorry if this is not the right place. My question is about, I just wanted to get a viewpoint around post-graduation in this field, or the online diploma courses that we have. A bit why I'm asking this question is, I've been into the IT field for a decade now, and always been surrounded with data and BI. Transforming into the data science AIML journey has been more through practical experiences and reading the blogs. Now,
Right.
I always have that feeling that is there something that I am not aware completely of, or will a post graduation really matter in terms of the industry experience?
So, Nikita, you already have a post graduation as in any other field, or
No, I've done my engineering in computer science.
and you're working in this area, is it?
Yeah, I've been working into BI specifically for a long time, and lately, since past 2 years or 3 years, into data science, AI, and related fields.
See, it's no harm to acquire a PG degree if you don't have one, because down the line, somewhere these things matter. So if it's possible for you to, pick up a PG degree, I would say so. Of course, depending on your circumstances. It's not a must. Like I've seen people with engineering degrees also do well, but at some point your competition kind of unfortunately becomes a lot with the PhDs and people who have done their MS or MTech in the relevant field, right? So given that you have had some exposure, if it's possible for you to pick up a degree, I think you should do that.
And I mean, just to get a little specific into that, so a proper post graduation from a university versus the online courses that are there, like on the online Udemy, Udacity. So, is there a specific view that you have around that?
Yeah.
I'm sorry if I'm getting into too much
No,
detail
no,
over
no.
here.
You can ask. I think the college and the pedigree matters, right? So if it can be done through any of the big institutes, it will be a plus.
All right. Thank you so much for your welcome.
Yeah, yeah, yeah.
Matangi, we have a lot of students here today. So, what is that one advice you would like to give? So, many of them would begin their career in this field soon, maybe in 2 years or 1 year down the line. So, what do you think, what should they do to get started? I mean, right now they're in that academic side, learning math, learning programming, or learning the algorithms in detail. But what would be that one thing they should do in addition to this academic so that it gets easy for them during their interviews and as they get into their jobs?
Sure. So see, they have to get depth, right? Given they are students, you cannot have real industry exposure. If you can intern, find your intern opportunities in companies, please do that. That's one big way to get entry into the field. Second is also figure out obtain depth, right? So it's not about breadth. It's not about many topics that you know. It's about knowing deep into certain things, right? Deep in math, deep in some of the fundamental concepts in math. Getting a good hold of statistics kind of helps. Plus, participating in some of the hackathons will also kind of give you some techniques, some ways to solve a problem. uh, Internship, and there are hackathon that industries also conduct, so that will also be interesting, because you not only solve the final hackathon problem but get a chance to present it to a panel of people, and they ask you questions. So that's one way for you to also understand what is happening in the industry and get connected. To summarize, internship if possible, plus in depth, like take courses that give you depth, plus statistics, plus hackathons, and preferably industry hackathons.
Thank you, Matangi. Any more questions? I don't find any more questions coming in the chat. Julian, do you think we can wrap up?
Yes, we can.
All right. I think Matangi, there are no more questions. So I thank you so much. This was a very informative session, and I think we had a lot of questions coming through. We also have this on YouTube live, so you can still go through the session on the YouTube link. And thank you so much, Matangi. It was pleasure having you here on the session.
Thanks, Vinita, and thanks, Julian. Thank you.
Yeah. So Julian has shared the link. You can watch the session. Those who have missed the initial part of the session can watch the session through the link.
Thank you.
Thank
Thank
you.
you.
Thanks, then.
Thank
Bye.
you, everyone.
Bye.
You have a great evening and
Thank
good
you.
Sunday. Thank you, everyone. Bye bye.
Bye bye.